Hello everyone. A very good morning, afternoon, and evening to all. Dear authors and invited guests, welcome to technical session 3C. My name is Anisha, and this session would be moderated by me. On behalf of Global Knowledge Research Foundation, it is my great pleasure to welcome you all to the 11th International Conference on Information and Communication Technology for Intelligent Systems, ICTIS 2026, Bangkok, Thailand. The 11th edition of the conference is being organized in a hybrid mode. The physical event will be held tomorrow in Bangkok, Thailand, and the virtual event is being held through Zoom from 9th to 11th of April 2026. I hope you will enjoy the knowledgeable and interactive sessions throughout the day. In this session, we have 10 presentations. Each presenter will be given 10 minutes for the presentation and 2 minutes for question and answers. And on 9 minutes, I will be raising a gentle reminder. There's another request to all the participants that you all stay connected with us till the closing of the session. And if you have any update or query, you can write it to me in the chat box. So before we start with the session, I would like to introduce you all to the chair for this session, Professor Ioannis Patias. Dr. Ioannis is an associate professor at the Faculty of Mathematics and Informatics, Sofia University, Saint Clement, Ordiski, Bulgaria. With over 30 years of experience, he specializes in mechatronics, autonomous and robotic systems, and project management. His research spans AI and future technologies, digital health, literacy, risk management, and intellectual property, focusing on innovation and interdisciplinary solutions. We welcome you to the session, sir.
Thank you very much. Thank you very much for introduction. Good afternoon, everyone. Welcome to the technical session number 3C. As mentioned, we have a great lineup of 10 research presentations spanning from machine learning, security, healthcare, and intelligent systems. And thank you very much for joining, and we may directly begin.
Sure, sir.
Our first presentation is a hierarchical latent retrieval model for constant time semantic query processing presented by Prabhat Kumar Gupta.
Yeah, sure. We'll be starting with the presentations, but before that, I would just like to introduce you all to the another chair for this session. We have Dr. Dipali. Dr. Dipali is an assistant professor at AISS MS College of Engineering, Maharashtra, India. Her research areas include data analytics, software engineering, and machine learning. She is actively involved in teaching, research, and academic development in emerging computing domains. We welcome you to the session, ma'am. Yeah. Now we'll be starting with the papers, and our very first presenter is Prabhat Kumar Gupta with the paper titled A Hierarchical Latent Retrieval Model for Constant Time Semantic Query Processing. Do we have Prabhat here in the session?
Hello, ma'am. I'm here.
Yeah. You can start your presentation.
Is it visible?
Yes.
Hello.
Yes, now it's
Yes, it is visible. You can go.
Okay. Good afternoon, everyone. Respected session chair, reviewers, and fellow researchers. I am Prabhat Kumar Gupta from final year Artificial Intelligence and Data Science from KPR Institute of Engineering and Technology. And today I'm presenting our work titled A Hierarchical Latent Retrieval Model for Constant Time Semantic Query Processing. This research focuses on redesigning semantic retrieval pipelines for latency-sensitive structured environments, where predictable response time is as important as semantic relevance. So, abstract. We proposed the hierarchical latent retrieval model, or HLRM, a deterministic semantic retrieval architecture designed specifically for structured query processing. Unlike a conventional system that depends on runtime vector similarity search and transformer Inference. HLRM shifts semantic intelligence into an offline compilance phase using bounded hierarchical root and semantic hashing. As a result, the model constantly achieves constant time 0-1 retrieval with 1 to 5 millisecond latency while scaling efficiently beyond more than 1 lakh knowledge units. Introductions. Semantic retrieval has been the backbone of modern RAG system, enterprises assistance, and domain-specific question answering platform. However, most existing pipelines still depends on vector search and LLM inferences, which introduce latency, scaling instability, and hallucination risk. In structured domain, such as academic, institutional, or enterprises system, the requirement is different. We need a deterministic, explainable, and trackable output with scalable latency guarantees. This directly motivates the needs for a constant time semantic retrieval framework. Comparative This is a comparative analysis for retrieval paradigms. Like in comparison to dense retrieval or RAG model, our HLRM model gives deterministic retrieval of 0, 1, which is the limitation. Like it is a structured domain only. In the structured domain only, like in small enterprises, institutions, such enterprises. Okay, literature survey. Here, the literature survey highlights the evolution of retrieval system from dense vector search to retrieval augmented generation. Dense passage retrieval offer a strong semantic matching, but still incurs runtime similarity cost. Colbert improves retrieval efficiency through late interaction, yet remains memory intensive. Semantic hatching provides fast lookup, but lacks hierarchical semantic routing. So our proposed HLRM combines bounding routing with semantic hatching, addressing the key gap, deterministic constant time semantic access. A problem statement. How what was the problem we tackled while working on the project? So we got this idea. The central problem in this existing retrieval architecture fundamentally depends on corpus traversal and runtime similarity operation. This causes query latency to grow with dataset size, embedding dimensionality, and inference depth. Such behavior is unsuitable for real-time academic assistance, enterprises help desk bot, and latency-sensitive structure system. The challenge, therefore, it is to preserve semantic relevance with guaranteeing fixed 0-1 query latency. So motivation of this research, like this research, we started our earlier college final year project with college RAG chatbot. So while working with the traditional RAG system, we went through the research. Then we find out about this. We need we were also needing like there was a high resource cost while using the traditional RAG system. So we introduced lightweight. The motivation for this research emerged from our early college RAG chatbot, which delivered strong semantic relevance in academic question answer environment. During deployment, we observed repeated embeddings, computations, trauma DB traversal overhead, and increasing response delay in institutional data grew. This practical bottleneck highlighted the need for a retrieval model that offers predictable latency, instant access, and hallucination-free output. So this is the methodology. The methodology is built around in two stages, deterministic retrieval pipelines. First, institutional documents are placed into automatic knowledge units, and intent response pairs are hierarchically grouped in semantic domains. Fixed length semantic hatches are then pro-computed and stored in a direct hatch table in indexes. During query executions, the output is normalized, routed through bounded semantic layers, converted into a semantic hatch, and directly resolved through 0-1 lookup. This key innovations here is that all computationally expensive semantic processing is shifted offline. Results and discussion. In the latency benchmark, this benchmark clearly demonstrates the performance advantage of HLRM, while dense hybrid and rack pipelines incur multi-stages search and inference overhead. HLRM consistently delivers ultra-low 1 to 5 millisecond latency. This is possibly because runtime embedding generation and LLM inference are completely eliminated from this model. Scalability analysis. This slide evaluates scalability with respect to corpus growth. As the knowledge base increases from 1000 to 1 lakh unit, dense retrieval and rack shows significant latency calculations. In contrast, HLRM remains stable at only 3 to 4 milliseconds, validating corpus independent deterministic retrieval. This is strong support our claims that HLRM behaves as an 0-1 semantic access framework. This is a scalability analysis across increasing query loads. Like we tested through different models. Like even our retrieval time was 1 to 5 millisecond. Conclusion. In conclusion, HLRM established a new deterministic paradigm for structured semantic retrieval by replacing runtime vector search and LLM inference with hierarchical routing and semantic hatching. The model achieves stable 1 to 5 millisecond latency scales beyond 1 lakh knowledge units and provides explainable hallucination-free output. This makes it highly stable for academic enterprises and other latency critical knowledge systems. This fundamental work provides the theoretical and architectural basis for our model, spanning rack system, dense retrieval system, late intersectional method, semantic hatching, and 0-1 hatch table theory. So, thank you for your time and valuable attention. I would be happy to take your questions, discuss the methodologies further, or explore collaboration opportunity through GitHub and LinkedIn.
Thank you very much, dear colleague.
Thank you, sir.
I have just a short.
Sorry, can you get it?
Before giving the word to the others, thank you very much. First of all, I have a short question.
Okay, sure.
What about the explainability you mentioned? You have something specific in the design of?
Yes, like
Yes.
explainability exists on like before igniting our data, giving to the database. We have to like our institutional data are mostly in PDFs, doc files. We always get circulated about code of conduct and other document. Like in that PDF data, all the there are topics and sub like their descriptions, like for ragging or anything topic or contents, that whatever content contents in the content area of the topic, that topic on the specific of that topic, it contains uh, hatching and store in the database on the like when the intent word matches, then the entire content which was under that topic, it comes as a output, which
Thank you
explain
very much.
how sorry, continue.
Thank you very much. Thank you very much. That means that you have you don't have it forgiven. You have undertaking some measures in the design of the system in order to make explainability easier. Thank you
Yes.
very much. Any other questions?
No, sir. Okay, thank you, sir. There's no
You
any
may
further
stop sharing
question.
your screen.
Sure.
Next, we have an efficient near collision attack for lightweight stream cipher presented by Kedhar Abodiamumdar.
Hello, sir. Am I audible?
We can hear you, we can see you, yes.
I'm not able to share my screen.
Yes, you may share your screen.
I request if any other participant is been sharing the screen, please stop it so that I can share.
You can share now. It will be open.
Yes, okay.
Okay, we can
Is
see
my
your
screen
screen.
visible?
Yes, the podium is yours.
Yeah. So good afternoon, everyone. My name is Professor Abuli Kedkar from Mumbai University, India. Today I will be presenting my PhD thesis topic, part of it, an efficient near collision attack for lightweight stream ciphers, A51. So the contents, this will be the content throughout the presentation. So mainly what is cryptography? Cryptography is the science and the art for securing communication and data by using mathematical techniques to make information unreadable to an unauthorized parties through encryption and decryption. So the cryptographic primitives are being classified in three different parts like not using key, symmetric key, and asymmetric key, where not using key does not use any key to convert the plain text to ciphertext. Similarly, asymmetric key uses two different types of keys like public key and private key, whereas the symmetric key uses a single common key for encryption and encryption. Now, in this symmetric key, we have two different types, that is stream ciphers and block ciphers. This research mainly focuses on the stream ciphers, where it uses bit by bit encryption pattern for converting the plain text into the ciphertext. So basically, we mainly focus on lightweight stream ciphers because the IoT device has many constraints like power, memory, and high computational, because of which lightweight stream ciphers are mainly preferred. Lightweight stream ciphers have high speed, they are simple and compact in the size. It requires low memory, low power, and low cost. So there are many different types of lightweight stream ciphers as been shown on the screen. The main focus of these are few lightweight stream ciphers and their application. We mainly focus on A51 stream cipher because it is being used in GSM technology, which is used in many IoT applications nowadays. So this literature survey shows some challenges for cryptanalysis techniques. Now, basically, before going forward, what is cryptanalysis? Cryptanalysis is actually a practice of analyzing a cryptographic systems with the aim to uncover the weakness findings and finding the vulnerabilities and obtaining the unauthorized access of encrypted data. So there are very different types of cryptographic techniques or cryptographic algorithms, also called as which are being used for encryption. But to check whether that algorithms has any weaknesses or vulnerabilities, we use some cryptanalysis techniques. So these are the few cryptanalysis techniques used on specifically on A51 and the different types of challenges that are being faced by achieve on this cryptanalysis techniques. So major challenges were the time complexity and the leakage information, key scheduling issues, blocking issues, and many more. Focusing on this, we mainly focus on the time complexities of the cryptanalysis techniques. So these are the time complexities given for various cryptographic algorithms as well as different types of cryptanalysis used on them. So the time complexity ranges from 2 raised to 13 to 2 raised to 406. Now coming towards the A51 cryptographic algorithm, this cryptanalysis table shows that the different cryptanalysis techniques with their time complexities, data complexities, and memory complexities. Recurring over to this table, the time complexity ranges from 2 raised to 16 to 2 raised to 48. Memory complexity is as low as in kilobytes to as high as in tens of terabytes if compared with TMTO attacks. Data complexity ranges from 2 raised to 15 to 2 raised to 32. So our focus was mainly to achieve a cryptanalysis technique which will give the more less time complexity, requires much more less memory, and the data used is also very less. So these are the few remarks from literature survey which we achieved from different for different ciphers and different cryptographic cryptanalysis techniques. So the research challenges that was faced was the size of the key was very high. So larger state sizes, strong non-linearity, rapid key diffusions, and cipher resist generic cryptanalytic techniques, making most practical attacks feasible only through the protocol limits or flawed implementation, rather than focusing on the design of the cipher. So we mainly focus on the design of the cipher and try to get the key of the algorithm. So what is this A51 string cipher? So this is the internal diagram of an A51 string cipher, where we see that there are mainly three LFSRs, which are named as R1, R2, and R3. R1 is of 19 bits, R2 is of 22 bits, and R3 is of 23 bits. Each of these ciphers are being clocked at, each of these registers are being clocked at different locations, like R1 is clocked at 8 bit, R2 is being clocked at 10th bit, and R3 is being clocked at 10th bit. Based on that, the final last bit are being XORed to get the output key string, which is Z50. So how this A51 cipher works? As we have discussed that LFSR of these ciphers are having three registers, R1 of 19 bit, R2 22 bit, and R3 23 bits. So first, we load the session key, which is of 64 bits, which has been XORed bit by bit into all three registers. So after that, the register is being clocked once for each key bit. Then we load the frame number, which is 22-bit JSON frame number, which has been XORed into the registers. And after that, the registers are clocked once. After this, the mixing phases come and the registers are being clocked 100 times using the majority clocking technique, which is being shown over here. Then, but at this time also, whatever output we get is never been used as a key string to produce the cipher encrypted data. But after that, after mixing phase, we now check the majority values of 0 and 1, and also check it with compare it with the clocking bits R1, R2, and R3, based on which if whatever register matches this majority value, that only registers are being clocked. Other all registers are being kept as it is. And with the next clock, the shift registers shifting process happens, where the clocked registers are being shifted right by 1 bit, and the new bits are being inserted into every register. Then after that, the generated key string bit is being formed, which will be the most significant bit of R1 and R3 XOR together. Then we repeat the process from 5 to 7 to get the final 64-bit key string. And now this key string is being used for encryption. So this is the mathematical primitive polynomial for R1, R2, and R3. And these are the mathematical key generation procedure, which we have just discussed. So here, with the majority bits, how the majority bits are being calculated, the formula is given over here. And if this formula's values is not equal to the clock bit value of each register, the same value of the registered values are kept same. Otherwise, the update R1 values are being called, which are being given by this formula. Similar process happens to R2 register as well as R3 register, and the final output Z of T is being represented by XORing the most significant bit of R1, R2, and R3. This is the encryption algorithm, the pseudocode for the encryption algorithm, and this is the pseudocode for decryption algorithm. These are the encryption and decryption output that we have achieved by these algorithms, which shows that the key stream used for decrypting the plain text can be achieved at the decrypted outputs. For encryption side, whatever plain text we have given, the same can be achieved at the decrypted side. Now, by till here, we were successful to generate or create our A51 cipher. Now we tried to do the analysis on cryptanalysis techniques called as guess and determine attack or GND technique. So there in GND technique, mainly they used all the clocking bits S8, S10 and S10 of R3 for guessing what can be the registered values. And by using that guess and determine attack, a new cryptanalysis technique was also there, seen in the literature, where it is called as move guessing technique. So in that, instead of waiting for clock guessing, where they were using 3 different clocks, here in move guessing technique, they were using only 2 different clocks, where the S8 bit of...
I would like to kindly ask you to shorten a bit.
Okay, sir. So in move guessing technique, major thing was to observe these mu and v equations, which we modified to our own mu1 and v1, which was our modification 1, modified move guess and determine technique. And this is the modification 2, which we suggested as mu2, v2. And by using this, we applied this on the near collision attack. So this is the process how near collision attacks happens, but I will not explain all the process of how near collision attack is happening. So this is the algorithm which the near collision attack was being performed. Based on this, the time complexity that was achieved by using the move guessing technique was 2 raised to 49.11 at the T cycle of 16th bit. Now by using our technique with S29 of mu1 v1, we was able to achieve 2 raised to 45.92 time complexity. And with our second modification, we was able to achieve the time complexity of 2 raised to 43.743. So this shows a major reduction in the time complexity. So this is the table of time complexity results. So our result shows it is the improvement of 13.86% with reference to move-based RP recovery, and the improvement of 17.76% with the near collision attack of ZAP. So data complexity and memory complexity that we were able to achieve was 32-bit and 2 kilobyte of memory capacity for all our different modifications with guess and determine as well as near collision attack. This shows the comparative analysis of time complexity, data complexity, and memory complexity with the existing techniques and with our proposed techniques. So the conclusion shows that the proposed technique for near collision attack, we were able to achieve 13.86% of improvement and 17.76% improvement from original near collision attack. So future scope says that we can be able to achieve more reduction in time complexity by using hybrid cryptanalysis model as well as signed channel and microarchitectural leakage studies. So these are the references. Thank you.
Yes, thank you very much. But dear colleagues, try from now on to be a bit more strict regarding your time. As mentioned in the beginning, each presenter will have 10 minutes in order to have some time for Q&A session. Okay. Any questions to the colleague? Please stop sharing your screen.
I would just like to know that you have only worked on the time complexity parameter for this particular experimentation which you have carried out.
Yes, ma'am. Only time complexity parameters.
What could be the different parameters which you could add to this?
Memory complexity and data complexity or other type of parameters that
this is related with attacks, right?
Yes, ma'am.
So, have you studied different type of attacks and how you are able to, like virtually, how you are able to defend it by this? Because your study parameter is only time complexity, right? So, how you can signify or how you are able to align with this particular point of attack?
Actually, ma'am, for A51 cipher, there are different types of attacks like near collision, guess and determine, then TMTA. Then we have algebraic attack, exhaustive key attack. So if I studied all the time complexity regarding to this all existing attacks, I can see that I was able to reduce the time complexity with the original near collision attack and my proposed technique. So major parameters in the literature that we were focused on time, data, and memory complexities.
Okay. Yeah, that's all from my side.
Thank you.
Thank you so much for the presentation. Moving on to the next presenter. Next up, we have Poonam Chaudhary with the paper titled Assessing the Performance of Quantum Machine Learning for Motor Imagery Brain-Computer Interfaces, Consumer Perspective of Wearable Electronics. Do we have Poonam here in the session? Or any of the co-authors of the paper, if they are here? Well, I guess she's not present in the session, so we'll be moving on to the next presenter. We have Subin Simon with the paper titled Autoregressive Mamba-based Structured State Space Model for Regional Monsoon Rainfall, Severity Prediction in Computer.
Good afternoon, ma'am. Am I audible?
You can start sharing your screen.
Okay, ma'am. Am I audible?
Yes, you are audible.
Can my screen is visible, ma'am?
Yes, you can start.
Okay. So good afternoon, everyone. My name is Subin Simon, and I'm from Amrita Vishwa Vidyapeenam, Coimbatore. So it's been a pleasure for me to present this conference. So the topic of my project is autoregressive Mamba-based structured space model for regional monsoon rainfall severity prediction, Coimbatore region. So Coimbatore is a place in India, which is in Western Ghats of Tamil Nadu. So moving on, these are the table of contents. Introduction. So introduction. Monsoon rainfall is primary source of freshwaters in many parts of India, and it plays a crucial role in sectors like agriculture, water resource management. However, rainfall patterns are highly variable across the regions and time. Climate systems are like non-linear and dynamic, which makes the rainfall prediction a challenging task. So we also observe strong and seasonal pattern along with the year-to-year variability. Although like extreme rainfalls are extremely rare, but they have a significant impact on like say, society as well as economy. So with the availability of long-term historic climate data, we have an opportunity to apply like data-driven approaches. So recent advances in deep learning and structured sequence modeling have shown great potential in handling such complex time series prediction problem. So next, I'll go to my problem statement. So we have monsoon rainfall exhibits strong seasonal behavior along with the complex temporal variability, that is, it changes with time, which makes accurate regional prediction very challenging. So traditional forecasting methods often struggle to capture the long-term dependencies in climate time series data, especially which patterns extend across multiple months or years, that is seasons. Therefore, there's a need for more structured deep learning framework that can effectively effectively learn the long-term temporal dynamics and provide the reliable rainfall severity prediction. So next, I have taken in the literature review, I have taken a few papers put in the PPT. So this is the Mamba linear time sequence modelings with selective state space spaces. So here, the Mamba model uses a selective state space, which is the main part of the Mamba model, which enables efficient and content sequence processing better than the transformer-based model. Similarly, the next paper is prediction of rainfall using intensified LSTM-based recurrent model in So in here, we also reviewed like LSTM-based approaches where enhanced architectures using linear input features for better capture of the nonlinear rainfall. Similarly, I have taken here for the next two papers, which I have taken is using the rainfall prediction enhancement using SMOT and machine learning algorithm. Here also, some studies focuses on handling class imbalance in rain data. For example, SMOT is a method which is used for class imbalance, for improving class imbalance. Next paper is the regression-based prediction rainfall energy management in Kerala. It's a southern part of India. So here also, we are using the micro hydro system. These approaches helps in handling and improving the reliability of the climate. So what is the research gap? So research gap is like, first of all, MAMBA model has not been applied too much to the climate or monsoon rainfall prediction. Second, the existing models like LSTM, GRU, transformer often struggle to capture the long-range spatio-temporal dependencies. In addition, transformers have high computational complexity, that is O of n square. So there's a lack of region-specific. That's why I'm taking the specifically region, Coimbatore region, which is my in the place where I'm studying, that is the Coimbatore. Further, previous works have limited integration using the multiple meteorological variables. Only less variables they are using. So finally, binary rainfall severity classification has not been widely explored. So the next, I'll go into the objective. The main objective of the project is to form a deep learning framework using MAMBA's structured space model. We aim for the long-term seasonal dependencies. So in here, I have taken the data set from the 1995 to 2025. That is an hourly data set. So next, I'll go to data set description. So data set I have taken from the ERA5 land reanalysis data set, that is from the ECMWF website. So location I have taken Coimbatore, and the latitude and longitude are the I have mentioned. Time period I have taken as from 1995 to 2025. So the original data is available at hourly resolution, which we have converted into monthly format for modeling the seasonal behavior. The features include total precipitation, temperature, dew point, wind components, and other wind speed, as well as both north to east and west to south. West to east and north to south are some of the factors we have taken. So this is the proposed methodology, which I will be. This is just a diagram I have kept, which I will be explaining. So pre-processing, the data set is used in the ERA5, which is provided by the ECMWF. The study focuses on Coimbatore region with the latitude of 11.106 north and longitude 76.958. So the data set covers a long range period from 1995 to 2025, which helps in capturing the long-term climate pattern. So the original data is available at hourly resolution. We have converted into monthly resolution. The features include, as I have mentioned earlier. So next is the feature engineering. In the feature engineering, we select key meteorological variables like influence the rainfall, such as temperature, dew point, etc. Wind speed is derived from the zonal and meridional wind component using the vector magnitude formula. So the problem is formulated as a binary classification task by defining threshold of 64.4. So why 64.4 is the standard standard in which above and below we can classify as normal and heavy rainfall. So next, the model which I've selected is MAMBA model. So this is just a flowchart what MAMBA model does. I'll just tell you in what that MAMBA model is doing. So MAMBA model processes the input sequence through multiple stages, and first the input sequence is then projected into two parallel branches. The first branch is the convolution and the activation, and that is the activation are applied to extract the local temporal patterns from the sequence, that is from the climate data. The core component of the MAMBA model is the selective structured space model, which models a long-range dependencies using the transition mechanism. This allows the models to retain the information from the previous time step. So what it has studied previously, it will be able to remember. The second branch acts as a gating mechanism, which controls how much information should be passed. Finally, the result is passed through the projection layer and normalization for the final output. So this is the testing part, like I have told. Then in the training part, the strict chronological data split is used. From data set is divided into training, testing, and validation. So with covering periods from 1995 to 2016, 2017 to 2020, and 2021 to 2025. So here I have used the The model is trained using weighted binary cross entropy, and the atom optimizer is used with learning rates I've used as 0.005 and batch size I've set as 32. So talking about the result part, so according to what my model predicted, the model achieved an overall accuracy of 88.89 and macro F1 score of 0.63. First, from the confusion metrics, we can observe that 62 normal rainfalls were correctly classified, while 4 were misclassified. For the heavy rainfall, 2 instances were correctly identified because 4 were misclassified. Because this is because the heavy rainfall, this shows the model performs very well for the normal rainfall classes, but struggles with the heavy rainfall. There's a reason for that, because extreme rainfall conditions are very rarely in the period which I have selected, that is from 1995 to 2000. That is because of that. So similarly, I have compared the LSTM and Mamba model. So in this work, the Mamba-based structured space model is for rainfall prediction. The Mamba model successfully captures the long-term seasonal dependencies using the temperature. It achieves a high classification accuracy compared to LSTM. Yes, ma'am. Thank you.
Okay, thank you, Subin. Dipali ma'am, Ionis sir, do you have any questions for him?
Yeah, I do want to know how are you able to handle the multivariate inputs through your model?
Ma'am, can you repeat? Multivariable?
Multivariate features could be there in your model. If I consider humidity, temperature, or something related with pressure, because these are some of the attributes which are associated. Yeah. So
Yes,
how this model will be able to incorporate, or how, because you have made just comparison with LSTM.
yeah.
Yeah.
So but in my project, like multiple meteorological variables such as temperature, dew point, wind component, wind speed, and precipitation are used as input features. So these features are like first pre-processed, and then they are standardized so that they are on a similar scale, ma'am, which helps in the model to learn them effectively. So after that, like all these six, mostly I've taken the 6 features mainly. So the 6 features are then combined into the feature vector for each time using since I'm using a 12-month sliding window. So these feature vectors are arranged into sequence, so that after each sequence, each input of the model contains information from the multiple variables that I have taken. So the Mamba model is able to sequentially learn from the input by learning both the relationship between the features through each time. Yes, ma'am.
Okay, if LSTM is using some like gated memory mechanisms, right? And what does your Mamba model is using or incorporating?
So Mamba model, what it is using, ma'am, it is using time complexity is very less, ma'am, O of n square. So that's why we are stressing it.
No, like the mechanism for LSTM, it is in time series, or you are having some memory mechanism which is associated with it, right? So what about Mamba model?
Like mechanism in okay. So, okay, LSTM. Okay, I understand, ma'am. Like LSTM, you're telling it is using time series. So in my model, what? Okay, so the Mamba model, what I'm working in is based on a structured state space mechanism. So where the input sequence is processed through a state transition time. So at each step, the model maintains a hidden state that carries the information from the previous time, allowing it to it captures the from the previous time. It can capture the long-term dependencies. So the model, the model first projects the input into different, like I have shown in the diagram, parallel branches, where one branch processes the temporal features, and the other acts, and the other one we can other one acts as a gating mechanism to control the information flow. So the core component, what differentiates from the LSTM, is like the selective state space model, which updates as I have told, it updates the hidden state using a state transition equation. So that equation is very important. That's why it plays that complexity comes in here. It has very less complexity compared to LSTM. So finally, the output from the different branches are combined to produce the final prediction.
Okay, over from my side.
Yes, I still have a very short question.
Yes.
Well, my question is, using the concrete data set, do you have the opportunity to capture the specifics of each local terrain, or it's a high level evaluation of the monsoon severity at the end?
So, I mean, this is a website in which it has all the, we can put any latitude and longitude, and it will give us all the features. So we can put from any year to year. So presently, I have taken from 1995 to 2025. We can take from, it has data
Yes,
set.
but the idea is that the concrete data set doesn't have fine scale local terrain. It's a wider level evaluation of the localities of the terrain each time.
Yes, sir.
The land surface and so on. Do you have any additional parameters or any additional data sets to cover those specifics?
No, sir. Like I have not added any specific parameters according to my data set. Only like those 7 features I have taken.
Okay. Thank you very much.
Okay, so for the next presentation, we have with us Priyanka P, who's going to present her research work titled as Calibration Weighted Ensemble with MCC Optimized Threshold for Lever Detection Prediction. So, Priyanka, are you here in the meeting? Let me check once. No, I think she's not. So we'll move on to the next presentation. So we have Jayanti J. Are you there in the meeting?
Yes, ma'am. Yes, ma'am.
Yes. So she is here to present her paper titled as Decoding Tamil Heritage Through Segmentation of Stone Inscriptions. So you can start sharing your screen. Yeah.
Yes. Thank you very much. So
Yes.
just a minute, I will share this. Hope screen is visible now.
No, yes, it is visible. You can start.
Thank you.
Yeah.
Yeah, very good afternoon to one and all. My topic is decoding Tamil heritage through segmentation of stone inscription. I'm Jayanti. I'm from Manipal University. Yeah, so this topic is focused on inscriptions. Just we are focused on the historical data taken from the diverse areas and getting the knowledge from that spaces. What's the main motive of this work? We compare to different languages and different.
Interrupt you. Sorry to interrupt you. We see a document. Is this what you share?
Yes, actually the PPT is not visible. There's a document. There's just a document.
Other things are visible. Okay, just a minute.
Yeah, now it is visible. You can start.
Yeah, sorry for
Okay,
the
now we
interrupt.
see the presentation.
Yeah, so as you know, you have a time limit of 8 to 9 minutes.
Yes,
So
ma'am.
wrap it up in it.
Yeah, definitely, sure, ma'am. Yeah, so my topic is decoding Tamil heritage through segmentation of stone inscription. So this topic is mainly focused on historical data. So we collected the historical data from the different areas, diverse areas. So from that, we are going to extract the knowledges. So for that, we used different inscription to find in the temples and especially so we taken from the Tamil Nadu places. And what is the traditional traditional method, what is the issue in the traditional method? They are taking the too much of time for consuming, as well as to digitize the data in the poor condition. The quality is very poor. So we thought that we can make an automation system to extract that inscription data and make it the knowledgeable information to the next generation. So for this, we worked only the as of now 2 level, and the third and fourth I'm not presenting in this conference. That is, I published in the journal paper. So this is the first two process of pre-processing and segmentation I'm going to present here. So what is the main that the motto of that the problem statement is? So preserve the valuable inscriptions to digitize the things. Already it is available for different languages in India, Canada, Telugu, Chinese, maybe in other countries, that is Chinese inscriptions. But compared to that, Tamil inscriptions are very less. So we thought that we can take from the Tamil Nadu area and taken some stone inscriptions, and we applied some pre-processing and segmentation technique. So for that, I taken different technique in the pre-processing. I'm going to say one by one. So what is the main objective of it? So we taken a camera capture image, and the first thing is pre-processing, because we have to enhance the images. The images may be affected by different degradation things, or maybe it is very dull. So we couldn't able to get the data properly. So the thing is, we applied first enhance the images and taking the characters. So we have to take each and every character uniquely. So for this, we taken the segmentation from a pre-processed image. So this is the architecture diagram. So I applied so mainly two part, as I said. So the first thing, that is the data taken from the cameras and stored in my database. So that I feed it into the different pre-processing technique. So I applied resizing, grayscale conversion, and binarization and blurring. And after that, I convert the normalization process also, and thinning and thickening characters, I apply the erosions and dilations. So once all the pre-step is over, I taken the script from the pre-processed and apply the segmentation technique. So for this, I used two main segmentation technique here. So one is I need line by line, another one is I need exact the characters. So I faced lot of issues in the thing as joined and overlapped characters. So that is also we are solving small problems we are solving, but not completely. So what are the modules in this? So data taken part. So the first I taken the images through the cameras, and after that I taken exact what is the images stored in the camera. So that is the outcome of it. So this is the image I shown here, some sample images taken from the temple war. So this image I taken from exactly the Tanjore temple. So this is some sample images I shown here. Then I applied a different pre-processing, that converting that image, color image, into black and white and remove the noises. So I applied blurring, erosions, dilations for enhance the characters, and I want to make a exact background removal of the images. For this, I apply the normalization process. So what is the input here? So here I given the input image as the script image, and I got it enhanced thing. So these are the way I followed the step one by one. So first enhance, the remove the noises and binarization. So this is the outcome I got it. So previously my images, my input is like that. So after pre-processing, I can able to just eliminate my background exactly such a way, and I can able to visualize my character in a better way. Okay, so even though if you are applying the more lighting, so I will face a lot of issues, but this image is giving the good result. And for that, I applied a different process. So I shown in the pictures different things. So one is the converted of the grayscales, and applied a different filtering technique and binarization. So finally, I'm getting the outcome in the normalization with proper remove of the background and getting exact characters. So next phase is I apply the segmentation. So for this, again, taking the individual characters. Again, what are the issues I faced here while doing the segmentation? Sometimes touching character and broken characters is very difficult to get it exactly. So sometimes we need a manual interventions. So we are solving that problem also slowly. So we are applying again other segmentation technique, but I am not showing this in our conferences. So for this, what is the pseudocode for that I used? So for the smoothing, I'm using the Gaussian filter. and handling the characters, so filling the mask and convex hull. So that will maybe give better than line as well as the individual character segmentations. So this is the outcome. So this is my binarized image as the input. So after apply the segmentation, exact portion of each and every characters I can able to take it. Then I'm using the exact technique as convex hull. So this is the image is showing here. So for this, I tried different test cases because so based upon the test cases, I know that which technique is working exactly for that. So the first test cases I taken with the indeligible characters, and second one congested character, and third one minor damage on broken characters. So last one minor damage, and finally converged characters I taken. So these are the case studies I shown here some samples. So TZ1 the compared to the TZ2, okay, so I can able to get the characters. And similarly TC3, so TC3 is the test cases of again the minor the damage and broken characters are there. So due to that I couldn't able to exact the character exactly because after pre-processing some of the portions are maybe that faded out. Okay, I couldn't able to get it exactly the characters. And TC4 I can get it, but the again I couldn't able to get it exact what is the letter is written. And the fifth one is congested character. So due to conjunction, because here what is the major issue is front end and back end, so both are merged. So due to the merging I couldn't able to clearly enhance the things. That's why without clarity I couldn't able to do the segmentations also properly. Okay, so this is the issues happen this kind of images. We can try multiple pre-process way to eliminate this kind of test cases 5 issues. uh, so now, so I shown each and every test cases. Then I can check it how I can validate how many samples I taken. So what is how I can say that algorithm is working in the fine manner. So I use the matrices. So total number of character present in the stone inscription and how much exactly segmented from the stone inscription, then multiply by the 100. So different test cases I taken in this. So for the first 2 test cases, I retrieved the characters in a good way. But TC4, again, the percentage will be less. But TC4, only 60 percentage. But in the fifth case, it is very bad condition. So the accuracy is very, very less than that. So finally, I applied whatever the technique for the stone inscription. The segmentation rate accuracy as per my data set, 88.8 percentage. So this is the way I compared all the test workers. If the stones is the intelligible characters, then we can get the good accuracy. If it is broken characters, or maybe it's very bad condition of very damaged one, maybe intelligible characters only less than 60 or 60 we can get it. So future work, maybe I can use the neural network. So I can feed as my segment character as the input to this neural network algorithm. And maybe I can recognize into or maybe translate into other language characters. Or maybe I can use CNN or maybe the LSTM for sequence sentences forming. Or maybe the continuous translation process I can apply. Okay, again, some issues in the segmentation itself. So we are working out some algorithms. So how we can try to improve more than 95 percentage. Okay, so still the progress is going on. And so this is a references I just taken. So only 4 I put it, remaining until I just mentioned in the research paper. Thank you. Yeah, so this is my presentation. So
Yes, anybody is willing to ask questions?
Yeah, which
Yes.
segmentation approach have you used? In this case, it is not mentioned.
Yeah, ma'am. I used generally I tried 5 to 6 technique, but I didn't mention everything in the conference. I mentioned in the conference line segmentations and vertical segmentation. So line segmentation for splitting the each and every line of it. Okay, that is the horizontal profile projections and vertical profile projection. And in the character segmentation, initially we tried in the form of simple vertical projection based upon the spaces, but it is not giving that much quality. So we moved into the bounding buses and convex and different techniques we tried. So one by one we tried. So based upon we are checking the accuracy. Actually, we are working in the previously in the DST project. So this is a very small part of the project.
Okay, and what about the data set? Are these actual inscriptions or you have taken some of the images?
Yes, ma'am. Exactly, it's inscription taken in the Tanju temple. It is in Tamil Nadu. It's a very famous temple. So we went to there and directly we taken each and every messages, photographs in our cameras.
And what was the data size? Like how many
Ma'am,
you
data
took?
size is very huge because the wall is very big. So almost we collected 1,500 images. So and the camera quality also good. But somewhere we tried with maybe the small, what I can say, DPI quality of the cameras also, mobile phones also we tried. So if we taken everything, then almost 5,000 plus, ma'am. If you are using the better camera quality, then we are getting at least the good recognition rate. And whatever the image we used taken through our mobile phone, so we are not getting that much. Maybe that reflections or resolution is not that much good.
Okay.
Yes, ma'am.
Yeah, over from my side.
Yeah, thank you, ma'am.
Yes, I would like to maybe recommend. You propose the pipeline of steps at the beginning, a sequence
Yes,
like capture,
from
segment,
the
and
camera.
so on. Sorry?
Yes, sir.
Yeah. What about some enhancement? Did you apply any enhancements in the beginning before trying to get to the segmentation? Because usually, apart the nose clearing, sometimes enhancing also helps.
Yes, sir. Actually, I applied different pre-processing in the manner of different filtering we tried. For example, the basics filters, whatever already they are using. So we tried with the median filtering, bilateral filtering, and we just tried histogram to project how the images, how we can enhance the things. So I think we try out 35 plus technique. Actually, I published one paper for separately this one. So we tried with the different pre-processing. Then after that, we are getting the conclusion. Okay, so we can try with this is the combo. Maybe we'll give this, maybe this kind of test cases. So we splitted with the different test cases first of all. So some test cases in the maybe the light background. Some of them is very dark background. So we put a different combination. Okay, maybe here we can apply median filter plus bilateral. So there we can apply maybe some histogram based filters. So this is the way we tried pre-processing, sir, but we don't have any single pre-processing technique as of now.
Thank you very much.
Thank you so much, sir. Thank you, team.
Okay, so let's move on to the next presentation. So next we are having Riman Kumar Roy to present his paper titled as Deep Eye, Interpretable Deep Ensemble Framework for Eye Disease Detection with GradCam Visualization using Eye Disease Image Dataset. So Ryman, are you there in the meeting?
Yes, I'm here.
Yes, so you can start presenting.
Is my screen visible?
Yes, it is totally visible. You can start.
Good afternoon, respected session chair, honorable reviewers, and fellow participants. I am Riman Kumar Roy, and I am presenting on behalf of my group. Today, I will present our paper titled DeepEye interpretable deep ensemble framework for eye disease detection with GradCam visualization. This slide shows the outline of my presentation. I will briefly go through introduction, problem statement, methodology, results, and conclusion. Eye diseases are a major global health issue. They can lead to vision loss if not detected early. Many diseases develop silently, so early diagnosis is very important. Deep learning helps in early and accurate detection. Is it scalable, cost effective, and supports doctors? GradCam provides visual explanation, improving trust in the model. Manual diagnosis is time-consuming and costly. Single models do not generalize well. Models are sensitive to dataset changes and struggle with multi-disease classification. Also, deploying these systems in real-world environment is still challenging, so there is a need for a better and more reliable system. Previous research shows good results using deep learning. However, many studies focuses on single models or limited datasets. Some works lack interpretability. Others do not combine different models' strengths. Our work addresses these gaps using ensemble learning and explainability. We focus on three main questions. Can ensemble learning improve accuracy? Can CNN and transformer together perform better? How can we make the model more interpretable? Our objectives are improve accuracy using ensemble learning, combine CNN and transformer models, add interpretability using GradCam. This slide shows the overall methodology of our system. It includes dataset, preprocessing, model training, and evaluation. For this research, we used eye disease image dataset collected from Anwara Hamida and BNNSB Johorul Haq Eye Hospital, Faridpur, Bangladesh, which is publicly available. The dataset contains multiple categories of eye diseases, along with normal eye images. In total, we use 10 classes including both retinal and external eye diseases, and the dataset have 1600 plus images. This diversity helps the model learn different disease patterns effectively. Image was normalized and resized. We applied contrast limited adaptive histogram equalization to improve visibility. Data augmentation was used to increase diversity. The dataset was divided into 70% training for model learning, 15% validation for tuning and evaluation, 15% testing for final performance assessment. This ensures proper evaluation. We use different models like ResNet, VGG, DenseNet, EfficientNet, and Vision Transformer. These models capture both local and global features, enables effective comparison, and improve classification performance. We tuned learning rate, batch size, and dropout. Adam W optimizer used for better performance. All models were evaluated using accuracy, precision, recall, F1 score, and AUC. Vision Transformer performed best among single models. In this slide, we present our proposed model called DeepEye. It is a stacking ensemble framework, which means it combines multiple strong models to improve performance. We use top performing models like VGG16, DenseNet, EfficientNet, and Vision Transformer. Each model learns different features from the images. Then we used a logistic regression meta learner to combine their outputs and make the final prediction. In addition, we integrated GradCam into the system to provide visual explanation. This combination improves accuracy, robustness, and interpretability, making the model more reliable for real-world use. This slide explains how our system performs eye disease detection. The model takes an input eye image and processes it through the trained DeepEye framework. It then classifies the image into one of the disease class or as normal. This system can detect multiple types of eye diseases, including both retinal and external conditions. This system can support doctors by providing fast and accurate decision assistance. In this slide, we present the overall performance of our model. Among individual models, the Vision Transformer achieved the best accuracy of about 90.11%. However, our proposed DeepEye Ensemble model achieved the highest accuracy of 91.34%, outperforming all the single models. The ensemble approach helped reduce misclassification and improve overall stability. This shows that combining multiple models can significantly enhance performance compared to using a single model. This slide shows the confusion matrix of three models. Our confusion matrix helps us understand how well the model is performing by comparing actual levels with predicted levels. The diagonal values present the correct prediction, while the off-diagonal value shows the misclassification. In our result, most values are concentrated along the diagonal, which indicates the model is making accurate prediction for most classes. There are very few misclassifications, those mainly occur between visually similar disease classes. This slide presents ROC-AUC curve. It shows the relationship between true positive rate and false positive rate at different thresholds. The AUC value or area under the curve measures how well the model can distinguish between classes. In our case, the curve is close to the top left corner, which indicates strong classification performance. A higher AUC value means better separability, and our model achieves a high AUC score, showing that it can effectively differentiate between normal and disease classes. This further validates the reliability and robustness of our proposed model. This slide shows the GradCam visualization results. GradCam highlights the important regions in the image that model uses for prediction. In our result, the model mainly focuses on the central corneal and limbal areas, which are important for detecting eye disease. This visualization helps us understand how the model makes decisions. It improves transparency and trust, especially in medical applications where explainability is very important. DeepEye improve eye disease detection accuracy, ensemble learning boost performance, GradCam adds explainability, making the system more reliable. In future, we plan to develop lightweight models, improve speed and efficiency, use larger dataset, further improve accuracy. This slide shows the references used in our work. We sincerely thank our supervisor, co-authors, and the Department of CC BUT for their support. Thank you, everyone.
Okay, thank you so much, Ryman, for the presentation. Any questions from the session chair sides?
No questions from my side.
Okay, thank you.
Thank you, everyone.
Okay, so for the next presentation, we have Lue Juma, sir, to present his paper titled as Drivers and Barriers to Implementing the Internet of Things in the Healthcare Supply Chain in Jordanian Hospitals. So, Juma, sir, are you there in the meeting?
Yeah, I'm there.
Yeah, so you can start with your presentation.
Yeah. Okay, can you see my screen?
Yes, it's visible.
Okay, great. Okay, good afternoon, all. I'm going to present the paper Drivers and Barriers of IoT in Healthcare Supply Chain. My name is Lai Jum'a. I'm an associate professor at the Logistics Sciences Department at the German Jordan University in Jordan. And I am from the business school, so this topic is going to be more management oriented than let's say technical oriented, and it will discuss the major drivers and barriers of adopting IoT in the healthcare supply chain. So, in general, my research focusing on supply chain management, logistics operation, disruptive technology, and sustainabilities, and I was recognized among the top 10% cited authors in this field based on the Stanford University and recognized by Elsevier. So, moving to our topic, I'm going to provide a brief introduction, then I'll talk about the theoretical framework that TOE that is used in technology adoption. Then I'm going to move to the methodology, results, discussion, and conclusion. Okay, first of all, when we talk about the healthcare supply chain, this is a highly complex domain in all countries, and especially the domain in the developing countries. And it is critical for patient outcomes. So there are many challenges in the healthcare supply chain, starting from the stockouts, inefficiencies, lack of integration, etc. So there is a huge need in this sector for digital transformation, and one of the suggested digital transformation is the adoption of the Internet of Things. So, the role of Internet of Things in the healthcare supply chain, it can provide real-time tracking through either the radio frequency identification, RFID, or through sensors. Also, it will improve the visibility and coordination between different members in the supply chain, especially when we talk about medicines. Also, it will enhance the decision making in hospitals and will provide more automation. And it's really important when we use cold chain, especially for some critical medicines. So, the TOE framework is a well-known framework that is used in technology acceptance, and it is categorizing the factors that affecting the adoption or the obstacle into three main categories: the technology, organization, environment. So, for example, in technology, we might talk about the infrastructure, compatibility, complexity. For the organization, we can talk about leadership, culture, and resources. And the environment, here we are not talking about the ecological things. We talk about the market environment, which is represented by regulation, competition, and ICT strategy. So there was a huge research gap in this topic, represented by limited focus on healthcare supply chain and IoT in Jordan. There is also a lack of integrated TOE-based analysis, and also the context-specific empirical evidence. As for the methodology, this is a preliminary study, and I used a quantitative analysis, and I collected the responses from 35 hospital experts that have a clear idea about the supply chain, its operation, and also familiar with the technologies. And also, I conducted a descriptive statistical analysis. I'm in the process of collecting more data so I can maybe, let's say, implement more advanced analysis. But for this study, the results were interesting, and I'm going to move to the results. Okay. As for the technological forces, I put the let's say the drivers and obstacles in comparison with in each slide. So for the technological forces in Jordan, The enabling or the drivers for adopting IoT is the relative advantage and the infrastructure readiness. So executive clearly understand that IoT will improve the operational efficiency and the basic networking capabilities for the hospitals in general. But their concerns were about the cybersecurity risk and the legacy integration. As for the legacy integration, it means how the system is updated. Because, for example, and I will move maybe to this point later on, in public hospitals, maybe they will face the legacy problem more than the private hospitals. So there's a high anxiety over making modern IT sensors to outdated hospital information systems and protecting the patient data. There are the major concerns in terms of using this technology. So they might be afraid of having a leakage in information, and the cybersecurity is a major concern. When we move to the organizational factors, the main driver could be the top management support. And as we know, most of the hospitals, they have a board of directors, and if the leadership is fully committed with the digital transformation, they will go for it and they will support the implementation of it. But the major concerns within the organization or the hospital, I would say, is the resistance to change, maybe lack of IT expertise in the employees, and also the budget constraints. So, despite the leadership commitment, there is like a combination of the maybe high cost, resistance, and skills gap, which might affect the adoption of the Internet of Things in hospitals. Moving to the environmental forces, I believe that government all the time they play a major role in supporting let's say the technology and the national digital transformation plans. They provide strategic motivation. However, also because like as a developing country, maybe we face some regulatory ambiguity. And for example, in Jordan, there is no clear policies about the legal framework of technology in general in the IoT or maybe the blockchain. And the other, let's say, barrier in this category is the supply chain coordination, lack of coordination. For example, if I am as a hospital, I can adopt the IoT, let's say, implement the technology of the Internet of Things, but my suppliers, they don't have, for example, the investment, or they don't want just to implement this technology simply. So, in general, to conclude, the major barriers and the major enablers in all categories. For the barriers, the budget constraints, cybersecurity risk, legacy integration, and regulatory ambiguity. And as for the enablers, top management support, relative advantage, infrastructure readiness, and government support. Okay, and from this study, we can see that there is a battle for the IoT adoption, mainly between the top management support, and as we said, we have like some barriers in the organizational factors, and also the capital starvation as a total lack of funding mechanism that prevent execution. Okay, there is an important point when we do the discussion for this topic is the comparison between private hospitals and the public hospitals. And I'm going to talk about these in three main dimensions. For example, the budget flexibility. As we know, in the private hospitals, they are able to allocate the capital for, let's say, IoT investment easily to secure the competitive advantage. Why? While in public hospitals, there is a lot of rules constraining how you deal with the budget, where the budget should go, how you should spend it. So this is it's not easy in public hospitals. So the budget flexibility should be taken into consideration when you talk about private and public. Another thing, the digital mindset. Again, in private hospitals, they are early adopters, driven by market competition. Usually the private hospitals also in Jordan, they attract patients from all over the world. While in public hospitals, which is mainly focusing on the local residents, there is a resistance to change, to be honest, and slower bureaucratic approval process for any kind of digital transformation. The most important thing which I talked about is the legacy infrastructure. In private hospitals, there's a higher baseline of modern ERP and e-health. There is like all the time decisions to improve the infrastructure and the technology used in the hospitals. While in public, let's say, hospitals in Jordan, there is heavily reliance on disconnected legacy systems. They try to use the system to the maximum, and the change is not going to be more frequently. It will take more time than the private hospitals. So moving to the, let's say, implications based on this study for the hospital administrators and, let's say, management, they should cultivate the digital culture based on the study results. Also, they need to make the integration with the different supply chain members and also upskill the workforce gradually. And as for the strategic roadmap for the policymakers and regulators, they should clear the ambiguity and also put, let's say, strict rules about how to secure the patient data and the specific, especially when using specific technology. Though also, there should be a capital injection. So, for example, the government can say, especially for public hospitals, there should be a dedicated, let's say, budget for improving our digital transformation, comprising or including the IoT, or maybe they can think of the PPP, the public-private partnership. The unify the chain. As for the supply chain fragmentation, maybe some rules or standards that can be put on supplier, distributors, and hospitals. So you will force the whole supply chain into to be aligned to each other. As for the conclusion of the study, IT has a strong potential to transform healthcare supply chain, but adoption is constrained by financial and structural barriers, and they were discussed in details through the TOE framework. And we should make a balance between technological, organizational, and policy approach. So, in order to be, let's say, successful, we need to focus on three, let's say, transformations to move from vulnerable cost centers to transparent value driver. So just we need to move from the idea that this is a cost and we need this value based on this cost. The fragmented logistics to more aligned logistics through the supply chain. And finally, from reactive purchasing to patient-centric precision. Thank you all. If you have any question, please let me know. And also, if anyone interested in more collaboration in this topic, this is my email in the below of this slide. Thank you very much.
Okay, any questions for him?
No questions from my side.
Okay,
Yes,
thank
Yeah,
you
please.
no
so much for
questions.
presenting.
Yeah, thank you very much all. Yeah.
Okay, so for the next presentation, we have with us Dang Thi and Tho to present her paper titled as Fraud Detection in E-Wallet Transactions, a comparative analysis of XGBoost and Random Forest. So, are you there in the meeting, Dang?
Yes.
Yes, so you can start sharing the screen.
Uh,
Yeah.
can you see my screen?
Yes, it is visible. You can start. Please wrap up within 8 to 9 minutes. You can start.
Yeah. Okay. Hello, everyone. Thank you for joining me today. My name is Anh Thơ, and I'm very excited to present our research, Fraud Detection in E-wallet Transactions, a comparative analysis of XGBoost and Random Forest. In this study was conducted by our team at Thương Mại University, and in the next 10 minutes, I will walk you through the problem, our approach, key results, and real-world implications. And let's get started. Before we dive in, here's a quick roadmap. The growing challenge of e-wallet fraud, why we choose XGBoost and Random Forest, our experimental setup, key results, what is the number really towers, practical implication, and the last one is conclusion and future direction. Let's begin. And the e-wallets are growing extremely fast in Asia Pacific, now reaching about 9.8 trillion United States dollars in transaction value. However, the more popular they become, the bigger target for fraudsters. Account takeovers, refund abuse, bots, and even deepfakes. Traditional rules-based systems can no longer keep up. That's why we ask a simple but important question. Between Random Forest and XGBoost, which one performs better for e-wallet fraud detection under real-world conditions of extreme imbalance and time dependence? And many previous studies have compared these two models in fraud detection. However, very few focus specifically on e-wallet environments, and even fewer used realistic time-aware validation, probability calibration, and cost-sensitive thresholds. And that's exactly the gap our study aims to fill using the PaySim dataset and a production like pipeline. And e-wallet transactions involve many stages: onboarding, top-up, P2P transfers, and payments, each with different attack surfaces. And fraudsters are becoming smarter, phishing, new accounts, ghost tapping, and AI-generated attacks. This is why we need adaptive machine learning models that can handle streaming data and concept drift. We compare two strong example methods. Random Forest, excellent at reducing variance and robust to noisy data, and XGBoost focuses on hard examples, has strong regularization, and handles imbalance very well. And both models were tuned with imbalance-aware settings and ensure a fair comparison. And we use the PaySim dataset, about 100,000 to 900,000 transactions, and focused only on transfer and cash out where most fraud occurs. And the more important part of our setup was time-aware forwarding training, train on past and test on future. And we tested 3 split ratio, about 70 per 30, 75, 25, and 80, 20, we apply smooth adhesive, hyperparameter tuning, and isotonic calibration. Evaluation metrics include precision recall, F1, PRAUC, the most important, and the ROC, AUC, and Brier scores. And now, let's look at the results. As you can see on the table 1, XGBoost consistently outperformed random forest across all split ratios. And the figure 1 shows XGBoost F1 score and PRAUC remain high and stable. Figure 2 highlights its superior spiration, and Figure 3 confirms its silent overall performance. An interesting point is that performance plateau after the 75% training split, meaning smart modeling master more than simply adding more data. And the table 2 summarizes why we recommend XGBoost, highest F1 score and PRAUC, best probability calibration, more stable when test window increase, optimal split about 75-25 time away. And in short, gradient boosting clearly wins for this problem. And 2 things stood out. First, XGBoost learns very fast and reaches saturation early, thanks to its step-by-step error correction. Second, it handles concept drift and training fraud patient much better than random forest. That's why its performance remains stable even with lengthy test windows, and the 75-25 split proved to be the perfect balance. So what does this mean in practice? For fintech companies, let's choose XGBoost as your main models and use the 75-25 time aware split, apply probability calibration, focus more on figures and brief monitoring instead of just collecting more data. And for regulators, please pay attention to PRAUC, Braille score, and time-aware validation when reviewing these systems. It will better protect users and increase transparency. And to conclude, our study clearly showed that XGBoost is the superior choice over random forest for e-wallet fraud detection, especially under extreme class imbalance and temporal dependence. It delivers higher F1 score, PRAUC above 0.88, and excellent calibration, and strong stability over time. We strongly recommend using gradient boosting with time-aware validation and calibrated probability in real operational systems. And thank you. That is from us. Thank you very much for your attention. I'll be happy to take any questions that you have.
Yes, I would like to know which hyperparameter tuning things you have used in your during your research work. Am I audible?
Yes, ma'am, you're audible.
Can you repeat the question?
Which hyperparameters have you used? Have you faced any problem of overfitting or underfitting when you were doing your experimentation?
In our study, we apply both research and Bayesian optimization to tune hyperparameter for random forest and XGBoost. And for random forest, we tune parameters such as a number of trees, maximum depth, and class weight to handle imbalance. And for XGBoost, we optimize key parameter, including learning rate, max depth, number of estimators, and especially scale pause width to address class imbalance.
Okay, then how you have prevented it, especially in which either in XGBoost or in random forest have you faced this problem? Where this hyperparameter tuning was most needed?
Yeah, we did face a risk of overfloating, especially with XGBoost due to its booting nature. And to prevent this, we apply regularization techniques in XGBoost, such as controlling max depth, learning rate, and using L1 per L2 panelists. And for random forest, we limited tree depth and use bootstrap sampling and feature randomness to reduce variance. In addition, we use time-aware validation instead of random split, which have prevent data leakage and ensure better generalization in real-world square nature.
Yashita, over from my side.
No questions from my side.
Any question?
So let's move on to the next presentation. So next we have Josu Piedra. Is he in the meet?
Yes.
Yes, okay. So he'll be presenting his work titled as SUE Mass, a secure multi-agent ecosystem based on LLMs for integrated university services using dynamic tool registries. So you can share your screen and start. Yeah. Yeah, it is visible. You can start.
Okay. Good afternoon, everyone. Today I will present SWEMAS, a secure multi-agent ecosystem based on large language models for integrated university service. Well, this work emerged from a broader thesis project on multi-agent ecosystem for student support, but this paper focused on one more specific question, that is how can we LLM-based agents in university service while keeping execution safe, controlled, and institutional reliable. Our goal was not to maximize autonomy for its own sake, but rather to explore how conversational flexibility can be combined with deterministic governance in a high-stake administrative environment. In many universities, student services are still fragmented across academic, administrative, financial, and support domains. This often leads to duplicated process, inconsistent response, delays, and strong dependency on manual workflows. At the same time, LLMs create an interesting opportunity. They can provide a single conversational interface for a student to ask questions, request service, and also navigate institutional process more naturally. However, in this case test, the challenge is not only answering well, the challenge is acting safety. If an LLM is connected to institutional tools, it might produce what the paper calls transactional hallucinations. And for example, the model can invent an identifier trigger a function with incomplete prerequisites or attempt an unauthorized system action. So the problem we address is that how can a university benefit from LLM-based multi-agent system without allowing the model to behave as if it had a unrestricted operational authority? There is already important work as LLM-based multi-agent frameworks such as AutoGen, MetaGPT, and other orchestrational approaches. These systems are very useful for collaboration, tool use, and task decomposition. But institutional service environment introduces a different requirement. In university transactions, the system works under what we describe as a closed world settings. That means identifiers, prerequisites, and permissions must be verified, not generated by the model. For example, a vacancy ID, a certificate, a period, or an eligible program cannot simply be guessed by an LLM, even if the guess looks plausible. This is the key gap addressed by SWEMAS, the system. The challenge is not generating multi-agent coordination. The challenge is governing multi-agent execution in environment where actions must follow institutional policy and validate the stats. So rather than asking whether agents can use tools, we ask, can they use tools only when they should? The main design principle of SWEMAS is the separation of reasoning from execution. The LLM remains important in the system, but its role is constrained. It supports semantic tasks such as intent interpretation, slot extraction, clarification, and conversational flow. Execution, however, is not left to the model. Actual operations are mediated by deterministic components defined by institutional policy. This thing is important. We do not remove intelligence from the interaction, but we also do not allow the model to directly control sensitive actions. In practical terms, the model can help understand what the student wants, but it cannot freely decide which raw tool to invoke, in which phase, with which identifier, or under which authorized state. And this design is what allows SWEMAS to remain conversational while still enforcing operational boundaries. Architecturally, SWEMAS is implementing as a configuration-driven multi-agent system orchestrated principal with LangGraph. In the backend is built on FastAPI. MongoDB stores agent profiles and session history, and pgvector supports retrieval for knowledge-based interactions. The system also integrates institutional or simulate external service. At the domain level, SWEMAS is organized around specialized agents. In the version presented, this includes certificates, vacancy, knowledge, resume generate, and bases. Also, in later works, the ecosystem was also extended with routing and scholarship support, showing how the same governance model can be applied across multiple university services. One important design choice is that the ecosystem is config-driven. Instead of hard coding all agent behaviors, SWEMAS use structural definitions such as agent profile, domain schema, and tool definition. This means that the agent can be defined through its prompt, the tool it's allowed to use, the required slots, validation rules, and execution policies. In the broader thesis implementation, the same ideas also reflect through shared states, agent profiles as a configurable brain of each agent, domain schema as data contracts, and session level control over candidates and tool exposure. This configuration-driven approach is useful for two reasons. The first, it improves maintainability, and second, it reduces the risk of compatibility overexposure because what each agent can do is explicitly bounded by configuration rather than left open-ended. We have the two main governance mechanisms in SWEMAS that are the dynamic tool registry and closed word action gating. And the first, the dynamic tool registry acts as a logical firewall for tool access. Tool exposure follows a deny by default policy. And before a tool is even made available to the agent, the registry checks whether the agent is allowed to use it, whether the current phase matches the tool phase, whether the policy predicates are satisfied, if the required slots are present, and the authentication is available if needed. So in this design, the LLM does not interact with raw institutional API. It interacts only with a governance proxy that exists if and only if all policy candidates are satisfied. In the second, we have the closed word action gating that prevents the model from inventing identifiers for right operations. Instead of allowing free-form IDs, the system keeps a session in scope, allowing derived from real service return candidates. This means that when a user search for vacancy or eligible certificate periods, for example, the return options are stored in a session stats. Later, if the user wants to continue, the system check whether the select target is actually present in that verified candidate set. And so the model might say that the first one or the vacancy, for example, in a city, Quito, but execution is only bounded to options already returned and validated by the system. And the model can guide the interaction, but it cannot fabricate operational reality. To make them more concrete, let me illustrate the vacancy agent, the workflow. The flow is divided into phases. We have three phases: discovery, detail, and apply. In the discovery phase, search tools are exposed only for search intents. The system returns matching vacancy and stores them as a session candidates. In the detail phase, the detail tools are exposed only if the request vacancy can be resolved against that cache candidate set. And finally, the apply phase, the application tool is only exposed if three conditions hold. The vacancy ID is in the verified allow list, the user is authenticated, and the required prerequisites are satisfied. So if a user on the model attempts to apply to a random vacancy ID that was never returned by the system, the action is blocked. Also, if the user has no authenticate, the action is blocked, and if the system is still in the growth phase, also the tool is not even available. So, so yeah, this example shows how is the governance in SWEMAS. About the resultant interpretation in the security evaluation, SWEMAS achieve a 100% block rate for invalid operation across adversarial scenarios um, such as phase. Sorry, this is the right depot. Yeah, for the knowledge chatting, the retrieval setup achieve 100% recall, and one faithful is on the valid dataset, and multi-turn coherence reach 4.5405, and the overage to the latency was 2.39 seconds. The most important interpretation is not simply that the system answered well, is that the system was able to refuse unsafe behavior while still remaining usable. Under this condition, if coexistent with strong retrieval performance, current multi-turn behavior, and acceptable latency. So, in conclusion, SWEMAS should be understood as a step toward a safer institutional adoption of LLM-based agents. Rather than a maximum agent autonomy, this work explores how to combine semantic flexibility for LLMs, deterministic governance from execution, and session-aware continuity for multi-turn interaction. The results are encouraged, but we don't know claim that this is the full solves every governance challenge. As a future work, the paper points to a human in the loop escalation for sensitive cases and broader domain support across the institutions. Yeah, thank you very much. I'll be happy to answer your questions.
Okay, so anybody, any questions?
Yeah, Yashita, I was just asking the candidate, like, could you just explain us in short, like, what are the different things which can be opted through this research work?
Can you repeat, please, the question?
Based on your topic, what are the different like things which can be, or which are the services which can be opted by integrating this system to or whatever services you are mentioning? So what are the different kind of services which we can use?
Okay. Yeah. Well, the different service that we can integrate, we talk about the vacancy, but also in the system we can generate academic certificates. Also, we can do recommendation about the scholarship from the university. In the scholarship, we use RAG, and
So
yeah, so
all
the
these things
person.
are being done by a single agent, which you are deploying over here by using LLMs and these things you were talking about in between the presentation.
No, it's based by a system multi-agent. This is a multi-agent system, so each specialized agent is yeah, is separate. Are different agents. It's not only one agent.
You mean to say a different agent will be deployed for each of the things, like if I have to generate certificates, or if I have to check out for the vacancies or resume generation, so everything is handled by a single agent. You are incorporating it in that way.
Yeah, it had depend. It had in the agent is not in, like I said, it's not in the same agent, the same agent, in only one agent. So, for example, you can only deploy vacancy or only deploy scholarships.
Okay, Yashita, over from my side.
Okay. So Patya, do you have any questions?
No questions from my side.
Okay. Okay. Then let's move to the next one. So we have Poonam Chaudhary. Uh, she is here to present her work titled as Assessing the Performance of Quantum Machine Learning for Motor Imagery Brain Computer Interfaces, Consumer Perspective of Wearable Electronics. So, Poonam, you can start. Also,
Thank you so much,
those who are
Rishita.
remaining with the presentation, there's a humble request to please complete the presentation in 8 to 9 minutes strictly, as it is already a little late. So please complete it as fast as possible.
Okay. Am I audible? I think
Yes, you are audible.
just let me clear my home screen so that I can present properly. Definitely going to take 8 minutes only. I hope my screen is visible. My presentation
Yes,
is
it is
visible.
visible. Yes.
Okay. Thank you. Good afternoon, everyone. I'm Dr. Poonam Chaudhary, Associate Professor and Postdoctoral Fellow in the Department of CSE, the North Cap University, Gurugram, Haryana, India. And my topic is like I have experimented motor imagery based EEG analysis for brain computer interfaces. I have implemented machine learning algorithms, deep learning algorithm, and I have compared the whole thing with the quantum machine algorithms. I wanted to do it, though there is a lot of research has already been done, but the only thing was not there is all of the experiments I have seen that is lab-based theoretical analysis. I wanted to do it to deploy the whole thing on consumer electronics directly. Like if we are talking about the lab part, then 64, 128 channels are there. But when we move towards the consumer electronics, there are 4 channels, 8 channels, and 22 channel devices are available. So when we actually convert the whole research from lab to deployable consumer electronics, it is not possible to gain the same accuracy with which we are gaining the in the lab. So I wanted to do this experiment so that we can directly deploy it there. Quantum, I know, I just wanted to find out that how the quantum is going to help me in that. So this paper is about that only. I have explored multiple algorithms. So this was the abstract. Let me just go to the next slide. Okay. So just wanted to give you the introduction. Like we can collect the electrical signals in a human mind, and after collecting that information and pre-processing, we can convert the whole signals into the control systems. The application for this kind of system is medical and non-medical both. In medical, you can use it for the rehabilitation. In non-medical, you can go for the smart home analysis, even AR gaming systems. And many neurotech startups have been funded by the US government itself. So I just wanted to move into this particular field. So you can see that multiple algorithms like LDA, that is linear discriminant analysis, support vector machines, and common spatial patterns. This is the, you can see in the on the screen that I have, this is the background, the literature review I have covered during this particular part. I have seen that multiple machine learning algorithm. Along with that machine learning, I have explored Riemannian classifiers also, which is worked on the spatial data specifically a lot, basically the topological structure of the human skull. Then some people have optimized their feature on the quantum machines also, like Zhang et al., Lalavat and all, Aksho and all. So these researchers has worked into these particular algorithms. So what I have did is like I have taken the data set which has been used by all these researchers. That is, you can say that most of the state of the art algorithm have been implemented on this data set. That is the BCI brain computer interface competition by German lab. Then I have pre-processed with the, as I am the person who work in signal processing also, so I have implemented and done my pre-processing a lot to make the signals to remove the noise and make the signals very a good shape so that I can convert with the machine learning and other help. Then after pre-processing, I have done the band pass filtering there in a fixed length and the temporal windows I have applied. After that, I have applied feature extraction. Especially when we are talking about EEG signals, it varies from user to user. It varies from one session to another session. And it is actually specially distributed over time. So the information is there as a spatial information as well as temporal information. To handle the spatial information, I have used common spatial pattern algorithm, which has been again there was in the literature only, and the filter bank CSP. So I have done the experiment with the both feature engineering pipeline. After that, I have applied quantum compatible feature engineering also, like Riemannian tangent space and principal component analysis, which is another very implemented algorithm by many researchers for the same field. Then I have trained my models like LDA, SVM from the machine learning. Even I have implemented deep learning algorithm, but I have not mentioned it in this paper because I am working on another paper also. So the results from deep learning I haven't included in this paper. I just compared the classical machine learning as well as the quantum machine learning. Then here, I just would like to say that the objective was to find out deployable consumer electronics. So the evaluation strategy was not dependent upon the accuracy only. I have included false acceptance rate as well as the latency, which are very important topic in wearable devices. Then after that, I have done the comparative analysis. So you can see that this is my methodology in this figure. The results were, I would like to show you in the table, it would be a little bit easy to understand. So again, the best performance was with the classical one, not with the quantum, but I can say that the quantum has almost reached the classical machine learning algorithms also. So the next plan is to work on the quantum parameter optimization so that I can decrease the latency and increase the accuracy also. So basically, these are the limitations and comparative analysis I have found, which is my future work for the same. These are the references I have used. Thank you so much. If anybody have any questions, I'm happy to answer.
No questions on my side.
Okay, so let's move on to the next presentation. Yeah, thank you so much, Poonam. Okay, so next we have Priyanka Haldar to present her paper titled as Topology Aware Botnet Traffic Detection Using Spatiotemporal Graph Neural Networks with Gated Feature Fusion. Priyanka, are you there in the meeting?
Yes, ma'am.
Yes, so you can start sharing the screen and start, and please complete it in 8 to 9 minutes, okay? Yeah.
Is my slide is visible?
Yes, it is visible. You can start.
So, hello everyone. My name is Priyanka Haldar from Jadavpur University, India. Today I am honored to present our research titled Topology Aware Botnet Traffic Detection using Spatiotemporal Graph Neural Network with Gated Feature Fusion. This work was guided by Professor Anupam Sinha, and our research addressed a critical gap in how we identify coordinated cyber threats in modern research and modern cloud infrastructure. So to understand why this is necessary, let's look at the limitation of our current system. My slide is changed. Hello.
No, it is on the first slide itself, the paper ID and paper title slide. Yeah, it is
Now,
changed now, yes. Yeah.
So in the traditional network intrusion detection system or NIDS, it suffers from what we call the static analysis bias. They treat network traffic as independent, isolated tabular records. So, however, modern botnets don't act in isolation. They rely on evolving collective interaction. And when we look at the individual flows, these are coordinated patterns. They are the coordinated patterns are hidden, and therefore the modern system have a fusion gap. They struggle to effectively balance the structural network contents with raw flow statistics. To solve this, we proposed our STG framework. So now see what is the STG framework. Our framework, the spatiotemporal graph encoder, model traffic as a sequence of dynamic communication gap. It consists of three main stages. The first stages is the dynamic graph construction, where the raw flows are converted into the snapshots. And the second is the spatiotemporal features learning using both GCN and GRU layer. And finally, the last step is our novel adaptive gated feature fusion, which acts like the dynamic mixing valve to balance the graph context with flow statistics. So let's break down the how we model this dynamic traffic. So, here we can say that the network traffic is never static. We utilize a sliding window approach to create the snapshot of a network over the time by mapping active IPs as a node and the flows as edges. Our model can observe the gradual real-time formation of malicious infrastructure. Without this sliding window, a standard GNN would not know if a network structure is either growing or shrinking or evolving into an attack. So once the graph is built, we extract the signature of the attack. So how we extracting? Here
we use a dual architecture backbone. So the graph convolutional network or GCN, which looks at the spatial like neighborhood to determine if the host is a either central hub, which is a potential attacker, or a spoke, which is a temporal potential victim. And when we use the gated recurrent unit, which is a GRU, to link these snapshot together, and this captured the historical behavior which distinguishing the steady of benign flow from the sudden coordinated spikes, which is spike of the botnet. And this create a unique vector that make it nearly impossible for coordinated attacks to hide behind normal looking individual packets. But how do we combine this structural data with the traditional statistics? So here is the core innovation of our work. Instead of just stacking the data, we introduce a lineable alpha-gate. The model essentially turns a node to decide which information is more important. Like a high alpha value prioritize the topological context, which is ideal for botnets, and while a low alpha value prioritize the flow statistics for for volume based anomalies, and this provide much needed interpretability to the detection process. And now we also have to deal with the fact that attacks are very rare compared to normal attacks. So here we use two dual loss objective. In the real world, the botnet traffic is like a needle in a haystack. So here often less than 0.1% of the volume. So to handle this imbalance, we use a dual loss objective. The first one is weighted cross entropy, which ensures that the system treats a single botnet flows with as much priority as a million of benign flows. And the second one is here we use the center loss. We can see here in the center loss. So this forces the sample of same attacks type of groove tightly in the around of the mathematical center of the latent space, and making subtle threats much easier to distinguishing from the normal activities. And to show the the result and analysis part, so here we use the CICID's 2017 dataset.
Yes, sorry for interrupting. You have 1 minute to close.
Okay, sir. Yes, sir. Okay, so here we used CICID's 2017 dataset, and we tested over 149,000 of data. And we can see in the results section, we achieved the ROC curve of 0.9998, and also our precision is around 100%. And in the figure 3, we can see that the alpha value we get that 0.992, that meaning that the model found topological context that is 13.2 times more informative than the static packet headers. And we also get a star topology here. This is the interaction pattern we can easily see. So yeah, this is the conclusion that we can say that we have successfully shifted the detection from independent record to dynamic graphs. By integrating the center loss and adaptive gating, we have achieved a high precision, high interpretability, and isolating star topology. Yeah, and this is the future work we will do. So that's all from my side. Thank you for attention.
Okay, sir, do you have any questions for her?
No questions on my side.
Okay, so the last two presentations for today. You can stop sharing.
Okay, ma'am. Okay.
Yeah. Okay, so up next we have Sonali Gaikwad to present her paper titled as A Robust and Efficient NLP Framework for Enterprise Ticket Classification under Domain Shift and Imbalance. So, Sonali, are you there in the meeting?
Yes, ma'am.
Yes, you can start and wrap up within 5 to 6 minutes.
Okay, ma'am. Okay.
As you had a chance, but you lost
Thank you,
that.
ma'am.
Yeah.
Madam, my presentation is visible with you.
Yes, it is visible. The screen
Okay.
is visible, not the presentation.
Oh. Yes. Is it visible, ma'am? Hello, ma'am.
Yes, it is visible.
Thank you very much, ma'am.
Yes.
So my
Just
topic is
summarize. Just
yes, yes.
summarize everything in short. Yeah.
Yes, yes. My topic is a robust and effective NLP framework for enterprise ticket classification under domain shift and imbalance. My name is Sonali Gaikwad. I'm working in Shivaji Science and Arts College, Chikli district, Buldana. I'm from India. So, in introductory topic, I'm explaining enterprise supports the ticket classification is a critical task in a modern service management system. It enables the automation, faster resolution, and improved customer experience. So, real world enterprise environment introduce the unique challenges not captured in a benchmark data sets. So it's an enterprise deal with a large volume of unstructured ticket data. Class imbalance leads to the balance model predictives. So organization handle a massive volume of unstructured support ticket data, making manual classification efficient and error prone. Several challenges arise in such a setting. So class imbalance, domain shift, frequency retaining, and over conflict predictions. So in a over conflict prediction can lead to the in incorrect automated decision, negatively impactful for the workflow and a customer trust. The challenges highlights the need for the robust, scalable, and effective classification framework. The problem statements. The task focus on automatically categorize enterprise support tickets, input, output, and task type. So in an input, the free text description of an enterprise support tickets. In an output section, a single predefined resolution category. And a task type multi-class classification. The key challenges lies in the decision. A key challenges lies in designing a system that maintain the high accuracy while being robust to the real world. Issues such as data imbalance, domain evaluation, and deployment constraints. So research objective for this, the primary objective of the research is to develop the comparative NLP framework for enterprise ticket classification that is the both effective and practical for the real world deployment. The study evaluates the models under the realistic condition, including the handle domain shift across time, addressing the class imbalance, ensuring the calibration reliability, the confidence estimations, the maintaining the efficient influence for the production systems. The key contributions, the work makes several important contribution for the proposed enterprise focus evaluation protocol that better reflects in a real world scenario, performs the comparative analysis of the classical machine learning model, transfer based deep learning model, and parameter effective fine tuning methods such as LORA. So provides the actionable insight into the model robustness under the changing condition, deployment,
feasibility in a enterprise environment. The trade-off between the performance and computation cost. So dataset overview. The dataset used is to the study consists of approximately 42,000 enterprise support tickets. So each ticket contains free text description of issues. Tickets are categorized into 7 resolution classes. The database exhibits the significant class imbalance reflecting the real-world distributions. The data splitting strategy to stimulate the real-world deployment condition, a time-based data split is used to the instead of a random splitting, 70% of a training set, 10% for the validation set, and a 10% for the domain test set. And 10% out of the domain test set, the approach ensures that the model are the evaluated on their ability to generate to future unseen data distributions. The processing step to improve the data quality and the model performance, several pre-processing steps are applied for the removal of a boilerplate text and email signature, normalization of the URL, IDs, and numerical values. Token sequences length is limited is a 256 token for a transformer model to the balance of a performance and efficiency. Model approaches. The classic machine learning model is a TF IDF plus logistic regressions, TF IDF plus linear SVM. These models serves as a strong baseline due to their simplicity and effectivity. Transfer by model, be it base, Roberta base, and D beta base base. The model the model conceptual to capture the semantic meaning more efficiently. The parameter efficient fine tuning to the technique to design the reduce computational overhead. Keep the model weight is a frozen, a small number of parameters, significant training cost and memory usage, achieve the performance comparable to the full fine tuning. The makes the highly suitable for the enterprise environment with the limited resources. The experimental result reveals the several important insights. The transformer-based model significantly outperformed the classical approaches, demonstrate the high robustness under the domain shift, achieve the near state-of-the-art performance with the stability, lower computational cost. The proper model collaboration is essential for the making reliable automation decisions. Challenges observed. Despite of a strong performance, several challenges persist. Ticket often contain multiple issues for the classification. Some descriptions are too short or ambiguous. Significant overlap in a terminology across the categories lead to the confusion. So conclusion about it, this study demonstrates the transfers-based model essential for the handling complex enterprise NLP tasks. So emerges as the most reliable model evolving environment. LORA offers an effective and scalable solution for the model retaining. Addressing the real-world challenges such as the domain shift and the imbalance is a critical for the deployment success. Future research direction includes for this exploring the multi-level classification to handle the tickets and multiple issues. So implementing hierarchical classification for the better category structuring, improving model collaborations technique for the safer automations. Thank you.
Okay, any questions for her? Or should I proceed with the last presentation for today? Okay, I think there are no questions. So let's move forward to the last presentation. So we have with us Hasina Islam to present her work titled as Statistical Learning Frameworks for Automated Detection and Classification. So Hasina, please start sharing your screen. Sonali, you may stop sharing. Yeah. Hasina, yeah, it is visible. You can start and wrap it up in 5 minutes, 5 to 6 minutes.
Thank you, ma'am.
Yeah, thank you, Sonali.
Good afternoon, respected chair, honorable guest, and dear participant. I'm very pleased to present our work, Statistical Learning Frameworks for Automated Detection and Classification. This research focuses on a hybrid Bayesian artificial neural network ensemble model for detecting electrocardiogram arrhythmias. Now let me explain why this problem is important. Cardiovascular diseases are one of the leading causes of death worldwide. So fast and reliable ECG classification is very important in hospitals. However, there are three main challenges. ECG signals contain noise and baseline drift. There is variation between patient and many arrhythmias look very similar. Also, deep learning alone is not always enough because it needs large data and it lacks interpretability. So our key question is, can we build a model that is both accurate and interpretable? Our proposed framework combines interpretable features with hybrid learning. We use MIT BIS ECG data, and we apply pre-processing like filtering and denoising, and we also extract two key features, cross-correlation and phase difference. We use two models, Bayesian neural network and artificial neural network. Finally, we combine them using weighted voting. The main contribution of our work is combining probabilistic reasoning with neural learning. Now, about the dataset and the evaluation. We use 48 electrocardiogram recordings from 47 patients, and we categorize them in 7 classes. No, the normal AFIB, PVC, Varacardia, Tachycardia, VT, and BA5F. Very importantly, we use a patient-wise split. This means data from one patient never appears in both training and testing. This avoids data leakage and makes result more realistic. We also use group k-fold validation and SMOT. SMOT stands for synthetic minority oversampling technique. It is used to solve the problem of class imbalance in the dataset. Before learning, we improve signal quality. The steps are wavelet denoising and bandpass filtering between 0.5 to 40 Hz and segmenting into 5-second windows. This is very important because it preserves ECG component like POFs, QRS complex, and TOFs. Good pre-processing leads to better features extraction. Now let's look at the first feature, cross-correlation. This measures how well two ECG segments align over time. For example, normal ECG, a sharp peak at zero lag, and the irregular rhythm depressed or shifted peaks. So these features capture temporal alignment and similarity. This is both compact and clinically meaningful. Now, the second feature is phase difference. This captures how signal synchronize changes. For example, normal ECG, a stable phase pattern. BA5B, highly irregular, and tachycardia, high frequency changes. So these features captures timing and synchronization. Together with cross correlation, we capture both alignment and timing. Now, the core of our model, we combine Bayesian neural network, which handles uncertainty and dependencies, and artificial neural network, which learns nonlinear class boundaries.
Just a
And finally,
reminder, you have 2 minutes remaining with your wrap-up page.
okay, I will try to finish. Then the result part. Now, the main result is our hybrid model achieves 99.4% accuracy, and Bayesian model is 98.6, and artificial neural network model is only 98.4%. So, our hybrid model is more accurate than the other two model. And if we compare, if we see the curve, then the confusion matrix also shows that that the diagonal a strong diagonal values highly accuracy, and the off diagonal are the most classes in diagonal element, most classes are above 98.5% accuracy. And so we can say that our model, our hybrid model is more reliable and reliable. If we see the ROC curve, we also ROC curve, and from ROC curve, the hybrid model is also well fitted. We also compare with other literature, and we other method, and earlier method achieves 84% to 98% accuracy, but our model achieves 99.4%, which is the highest. So, the main strength of our model is that there is no leakage. And real-time performance, and more ablation stat. But the limitation of our studies is only one dataset used and real-time performance not tested. And we should compare with more method. We only use very few deep learning method. We should compare our model with more deep learning method. Thank you. I and my co-author Shohidul Islam are here to answer the question.
Patia sir, are there any questions from your side? Okay, I think there are no questions. So, okay, so we have come to the end of this session, and I sincerely thank all our authors for their excellent presentations and valuable contributions, and all participants for being an important part of this international conference. I truly hope that this session was insightful, engaging, and inspiring for everyone. So, on behalf of the entire team, we thank you for your continued support, not just for this 11th edition, but for all the previous 10 editions of ICTIS. We look forward to welcoming you again in the 12th version in 2027. All presenters will receive their digital certificates via email within 2 working days, and the publication will be live within 7 to 8 months. So, we kindly request your cooperation with the ICTIS 2026 team. So I would also like to extend my sincere thanks to our both the session chairs, Ionis Patia sir and Dipali ma'am, for their expertly chairing this session. So a small token of appreciation on behalf of Team ICTCS and the Global Knowledge Research Foundation and partners. So thank you all once again for your valuable presence. And before we officially wrap up this session, we have to capture this moment. So I kindly request everybody to switch on their cameras for a snapshot. I will quickly click a snapshot. Wait. 1 second. Okay. Rayman, everybody, please, yeah. Okay, so thank you so much everyone for joining. Stay safe. Take care, everybody.
Bye bye, everybody.
So much.
Bye. Yeah.
Thank you so
Thank
much.
you all. Thank you.